Welcome you all for Department of Collegiate and Technical Education video session number 5. This video session number 5 is a continuation of video session number 4 of Engineering Mechanics and Strength of Material course of our third semester of Civil Engineering Department, so our Civil Engineering program. This is also a continuation of Unit 1 Introduction to Engineering Mechanics. Let's move on to next slide. Table of content. Recap of the previous session. Moment, Varignon's theorem or law of moment, couple, equilibrium conditions, numerical problems, recap of previous sessions. In recap of previous sessions, we have covered the topics moment in earlier session also. Here we will cover the difference between moment and couple. We will brush up the video session number 4. I kindly suggest everyone to watch the session number 4 video before viewing this video session. Moment is a product of force and perpendicular distance. It is also it produces a rotational effect on the body. Moment is a product of force and a perpendicular distance of the force from the axis or point of rotation, where the moment of the force or a torque gives a rotational effect on the output of force on the body. And here in this figure, the A and B is the member with forces acting on a with a certain distance D at point B, the point of application of force is on B, and the rotation point, the point of rotation is A, where it will have where the moment is generated, like moment at A. F is a force, magnitude of the force. Then for the force F shown in the figure, moment about the point A, moment about A will be equal to force into perpendicular distance, that's F into D. Moment is equal to force into perpendicular distance. So a moment is calculated or designated in the form as shown in the figure. Moment, here are the two examples of moment where while removing the screw from the spanner, as we actually create the moment, the force is applied is at a distance from the point of rotation. And here while opening the door also we apply force at the end so that it can be easily opened. These are the two examples for moment. Next, couple. The couple is a two force or have same magnitude acting in opposite direction, that which are acting along the same straight line and separated by a distance. The couple produce only rotational without any translation. It produce rotational effect. As in the case of driving a car, steering, the force is applied in two of same magnitude force is applied at a certain distance opposite to each other. The force applied is opposite to each other. This creates a rotational effect which is called as couple. And here in case of paddling the cycle, here also we apply force in two different opposite directions at a certain distance. The couple is formed and it gives a rotational effect. You can see clearly the motion of the steering, that the force applied here on the two sides equally, then only there will be a rotational effect which forms a couple at a certain distance which is equal to the width of the steering. And here in second illustration, the figure shows that rotational effect take place when cycling the paddle, which has two different forces in opposite direction, and It produces a rotational effect where the two forces are at a certain distance apart. The rotational effect produced by the couple is known as moment of a couple. It is the product of magnitude of the force and any perpendicular distance between two forces. It is the product of magnitude of any force and the perpendicular distance between the two forces. The couple can be classified depending upon the sense of rotation of the moment as clockwise or anti-clockwise. Moment versus couple. Here in this figure, the moment is applied with certain distance to rotate this pipe, where force is applied in this direction and the will be rotational effect will be in this direction, which the magnitude of the moment will be m is equal to force F into distance. Distance is 200 mm here. And in case of couple, while opening this uh, gate, circular wall gate of opening valve, this we have to produce 35 kilonewton. Showing the figure, 35 kilonewton is acting at a distance from here, which is 175 mm, and 35 kilonewton acting which is opposite in direction, which creates a couple. What is the difference between moment and couple? Moment and couple. First difference: the moment of the force is turning effect caused by single force. It has a turning effect. Rotational effect will be there. A turning effect we can call. It has a turning effect by a single force. Here only single force. In couple, it consists of two forces which has same magnitude and opposite in direction. Here two force. Here only single force. Moment has single force. Here two forces. Moment is caused by single force. Here a couple requires two force to form. Next, moment of the force is different about different point in plane. Moment of the force is different about different point of plane. For every point of plane, it will be a different magnitude. But the moment of the couple is same about any point in the plane. It will be same in any point in the plane. The moment will be different in the point in the plane. But in case of the couple, the moment in the couple will be same about any point in the plane. Moment of the force is zero about any point on the line of action of the force. It will be zero at the line of action of the force. Then moment of the couple is same about any point in the plane. It will be moment of the couple will be same about any point in the plane. In case of moment of the force will be zero about any point on the line of action of the force. When we apply a force on a door, it produces a moment about the hinges which opens the door. Here, the opening the door is the example for the moment. In couple, to open the tap, we have to apply actually the two couple forces is required, and car steering while driving car steering also we require couple will be couple is required to introduce to steer the car, and paddling the cycle also there will be generation of couple, and unlocking the key also the couple is used. Equilibrium conditions. What is equilibrium condition? In any structure or any body, it is said to be in equilibrium when all the forces acting on the body is equals to zero, or all the moments acting on the body is equal to zero. What does it mean? It means like this: when the force is acting in this direction, if the force is acting in direction 10 kilonewton and 20 kilonewton, the body will move. This is not an equilibrium condition. It actually moves. But when we apply the force here 20 kilonewton and 10 kilonewton in this direction also, the body will be in static condition, as the total force over here will be equals to 0, where 20 plus 10 and minus 20 and minus 10, this is minus 10, then only it will be in equilibrium. Now if it is 20, then it will not be in equilibrium, the body will be in motion, and it is not said to be an equilibrium condition. Here all the forces, when we sigma h, these are all horizontal forces here, 20 kilonewton, 10 kilonewton, or 20 and 10, this will all be horizontal, this will be 0. Do we need only one condition to satisfy the equilibrium condition? No. This is one of the conditions to describe the equilibrium condition. The other conditions are, next one is vertical forces. Vertical forces should also be 0. In the sense, if body is lifted here, body the force is acting on a body of 20 kilonewton and or 30 kilonewton. If the body takes the reaction force here, then 20 and 30 reaction force will be there, and then the body will be equilibrium, because 20 and the two opposite force will be deducted 0, like 20 plus minus 20 and minus 30 and plus 20 plus 30, it will be 0. Again, sigma v in this condition, sigma v is equal to 0, then the body will not move and body will be in static condition. Suppose when there is only 30 load, and we are trying to lift with the help of the 30 kilonewton load, then there is no counter force, then the body will be in motion, then it is not said to be an equilibrium condition. And last, the third condition, the moment. If at any point of the body, the moment of sum of all moment should be equals to 0. If these three conditions are, if it satisfies these three conditions, then only it is said to be equals to in equilibrium condition. Then only it is said to be in equilibrium condition, or in static condition, Can I clear this? The body is said to be equilibrium when it is at rest. When it is at rest, there is no motion, it is in static condition, then it is said to be in equilibrium condition. It means the resultant of all forces acting on the body is equilibrium. It is in the body is equilibrium is 0. When all the forces in the body, if it is equal to 0, then the body does not move, body will be rest, or body will be in static condition. If any forces which are, if it is not equal to 0, then the body will be in motion, and it is not said to be in static condition, or it will not be at rest. The first condition is the algebraic sum of, as we explained just now, the algebraic sum of the horizontal component of the force along each of the two mutual perpendicular direction is 0. In x-axis, sigma x is equal to 0. As I said, when force is applied on the body, then this certain F force is applied on a body. This body moves. When it will be equal to 0? Then horizontal force, overall summation of horizontal force, when it will be 0? Only when the opposite force is also equals to F. Then F minus F, then summation of horizontal force equals to F minus F, then it will be 0. Then in this condition, this body is said to be in equilibrium condition, or at state of rest. Second condition, the algebraic sum of the vertical component of force along each of the mutual perpendicular direction is 0. Same way here also, when body is applied vertical force F and vertical force which is the same magnitude, then the summation of all forces, that is sum of all vertical forces, will be equals to 0. Sigma v will be equals to 0. In this case, the body will be said to be at rest, or it is in equilibrium condition, because sum of all the forces will be equal to 0 here. Next, that sigma h equal to 0 is the first condition where all the horizontal force will be equal to sum of all the horizontal force will be equal to 0. And next, second condition is sigma v is equal to 0 where all the vertical component of the force is equal to 0. And third condition is the algebraic sum of moment of all force about any point in the plane is 0. The sum of all moments, the summation of moment should be also be equal to 0. That rotational moment is 0. The sum of all the moment at any point should be equals to 0. Then only the body is said to be in rest or it is in equilibrium condition. Sigma m is equals to 0. Next, let us see the illustration example. When force, as I explained earlier, this now the card pyramid what we play games, it is in equilibrium condition now, that all the forces acting on it is equal to 0. Here whatever the load on this force, the horizontal force the acting on it, or horizontal force acting on this will be equal to 0. In the same manner, the reaction here, it has reactions. So the weight of this card will produce the load, and this will be the reaction, and it will be equals to 0. In same manner, every such will have reactions, and reaction due to the load will have, due to gravity it will have weight is also called a kind of force, or load is also kind of force, and it will have a force effect. And this will but all the forces will have particular reaction to so that each force have a negative reaction, which makes the body which makes the vertical sigma v equals to 0. And horizontal force here, even in horizontal force, if there is any horizontal force, then it will be equalized by another horizontal force, so that it is in equilibrium, it will be in equilibrium condition. But any force, if we apply any force which is not equalized, it will not be equalized, or external force which cannot be equalized here, then whatever the equilibrium condition or state of rest will be, it will be in motion. It is not said to be an equilibrium condition. The pyramid is in equilibrium condition at present, but if we apply any force on this, if we apply any force, then there is no equalization force here, then sigma h is not equal to 0, then the equilibrium condition is disturbed and that is in motion. The same manner, when the two forces two forces acting in this body, when it is considered this as a weight of 10 Newton, and this is other 10 Newton, which is balanced by its center of gravity 10 Newton, to be sigma h equals to 0, to form a sigma h is equal to 0, there is no horizontal force here, of course sigma is equal to, in case of sigma v is equal to 0, to make vertical force 0, here the weight of this sphere is 10 Newton and this sphere is 10 Newton, then the reaction formed will be of 20 Newton. Then only the body is this, what the setup or a body will be in equilibrium condition. If the force here 10 Newton or 10 Newton, and the distance between these two, and between this 2 meter or 200 mm, 20 mm or 20 mm, just assuming it, then the force formed here will be equal, and this forms 20 Newton and reaction force. Then this setup will be in equilibrium. If assume that one force is having the lower 5 Newton in case of this, Let us suppose this one is 5 Newton and this weight is 10 Newton, then there is a possibility a distance between the two is 50 mm and 50 mm. Distance between two is equal, then there will be sigma m equals to will be not be 0 because it will produce different moments, and also sigma h will not be sigma v will not be equal to 0, where the 5 Newton and 15 Newton, the reaction will not be here because the distance is same and the moment formed in two cases with respect to this point will be different, and sigma m will not be equal to 0, will not be equal to 0. Sigma m will not be equals to 0 and sigma v will also will not be equals to 0. In this condition it is not said to be an in equilibrium. I hope you understood the concept. Let's move next slide. Resultant of number of coplanar forces. Coplanar forces, let us assume the coplanar concurrent forces. When force is acting on a in the form concurrent forces, if it is acting coplanar concurrent forces, then each force, if the angle with respect to the x-axis of all the forces are known, all the angle with respect to all the forces are known, then the force F1, F2 and F3 and F4 can be the resultant of all these forces can calculated by the formula by calculating sigma h and sigma v. What is sigma h? F1 cos theta, force F1 and cos theta 1 and F2 cos theta 2, this is theta 2, theta 3 and theta 4. F2 cos theta 2, okay, this is 2, 3 and this is 4. Okay, F2 cos theta 2 plus F3 cos theta 4 and so on, F4 cos theta 4. Same way, these are the horizontal component. If we split the force into two, one is horizontal component and one is vertical component, we have summation. This is sigma h is the sum of all horizontal force, where all the horizontal component of each forces is added here, is summation, and then we'll get sigma h. In the same way, if we add all the vertical forces, that is vertical force will be F1 sin theta 1, F2 sin theta 2, F3 sin theta 3, F4 sin theta 4. If we add all this vertical component force, then there will be we get sigma v. Sigma v equals to F1 sin theta 1 plus F2 sin theta 2 plus F3 sin theta 3 in case of coplanar concurrent forces. The resultant force what we get will be R is equal to square root of sigma h square plus sigma v square. How we get the formula is 90 in triangular law of forces. We can consider triangular law of forces. Even parallelogram law of forces also we can take, where parallelogram law of forces R equals to P square plus Q square plus 2 P Q cos theta where cos theta will be equals to 90 degree of cos theta will be equals to, this content will be 0, then R equals to square root of P square plus Q square. P is the vertical component, Q is the horizontal component, or we can write simply R is equal to h square plus v square. R is equal to square root of h square plus v square. It can be derived in triangular law, as per triangular law also. I have derived it from as per parallelogram law of forces. Then the angle made by the resultant R with the x-axis theta is given by direction. Then the resultant force which will have direction, then direction will be tan theta is modulus of sigma v divided by sigma h. Vertical, the sum of all vertical component forces divided by sum of all horizontal component forces. Let us in what does this modulus significant? What does this say? The modulus indicates that the sign, whatever the signs, the positive or negative, it should not be considered in the finding out the direction of the resultant. When what is how will get negative sigma v will be negative or sigma h will be positive whenever whenever it lies in which quadrant. If it is in first quadrant, both are positive, and here v and h are positive. Here v h are positive and negative, and here v h will be both negative, and here v h will be negative and positive. In this case, when sigma h and sigma v, depending upon the sign convention, we can decide which quadrant the resultant lies. This will be very clear when we do the numerical problem. Just understand this. We have to the first step of calculating the resultant force is to calculate the horizontal component of all forces, and adding that summation will get horizontal component, and summation of all vertical component forces will get sigma v, which is the summation of vertical component. And by getting this, we have to find out the resultant by this formula, square root of sigma h square plus sigma v square. Then to find the resultant of the resultant of all these forces and its direction of the where it lies, actually where first quadrant, third quadrant, or second quadrant, where it lies. We have to observe the signs of vertical and horizontal component and decide if it is plus and minus, vertical component plus and horizontal component is minus, then plus minus is second quadrant, it lies in second quadrant. It lies in second quadrant. Next, theta is obtained with respect to tan inverse sigma v and v. What theta v, what we get in this formula, we will be always with respect to x-axis. This is very important. Which will be always with respect to x-axis. Only with respect to x-axis. Whatever we denote the resultant, or we draw the resultant force in any of the quadrant. But theta v, what we receive, will be in with respect to, if the resultant force is here, or theta will be here. If the resultant force is in first quadrant, then theta will be with respect to x-axis. Theta, in case of third quadrant, theta will be of this quadrant, where theta will be with respect to x-axis. And in second quadrant, in third quadrant, theta will be in all the cases. Theta will be with respect to x-axis. Whatever the theta resultant direction we get, it will be with respect to x-axis. We have gone through this particular picture where it shows the quadrant wise positive and negative signs of the resultant force. The resultant force both are positive. We just explain now resultant force both are positive. Then it is first quadrant, first and minus, second quadrant, both negative, third quadrant, and minus plus fourth quadrant. We have finished how to calculate the resultant force of a coplanar concurrent forces. Now the resultant of a parallel forces. In parallel forces, mainly we'll get the problems on the below figure. Here, these are all vertical forces here, as shown in the figure, vertical forces. Now, in order to find out the resultant, we should know the horizontal component and vertical component of each forces. Since all the forces are not in an angle, there will be no horizontal and vertical component of each forces. It will be directly all are vertical forces. There is no horizontal forces here. Then it will be equals to 0. If there is any horizontal forces, we have to add the horizontal forces also. Sigma v is equal to sigma v is equal to, we should add all the vertical forces here, F1, F2, F3, F4 are all the vertical forces which has vertical forces, and vertical force we should add each one of them, all F1 plus F2 plus F3. In order to indicate it that it's vertical, I have given the suffix that F is equal to V, which is third, which indicates the vertical forces. If there was any horizontal force, we would have named it as FHV1. That for horizontal, it indicates horizontal force, and first force or in same manner H1, H2, H3. Next, yes, sigma H is equal to calculate sigma horizontal force FH1, FH2, F3. There is no horizontal force here. This will become sigma FH1 equals 0 in this case of figure. Next, the sigma V equals to FV1, FV2, FV3, FV4, so on. How many forces are there? We have to all add it. We have to calculate it. But in this case, there are they are parallel forces, but they are in different direction. What will be the sigma V in this case? In sigma V will be in this case, F1 is in downward direction minus FV1, and plus FV2 is minus, again it is a minus FV2, where I will write it in black bracket, plus FV3. Why it is plus? Because it is moving in upward direction. These both are in negative direction, downward direction negative, and upward direction positive. Then minus FV4, which is in downward direction. This will be the sum of all vertical forces, that is V component, sigma V, the summation of V in particularly for this figure. Next, to calculate the resultant, we have to substitute this sigma H and sigma V in this resultant formula. Resultant formula R is equal to square root of sigma H square plus sigma V square. In case of direction, R is equal to, where resultant force is equal to directly F1 plus F2 plus F3 plus F4. Here there are no horizontal force. Since there is no horizontal force here, horizontal force will be 0. 0 square is 0, plus vertical force sigma V square is equal to sigma V square is equal to sigma V. This itself will be the sum of all vertical forces, will be the resultant. That's why I have written here R is equal to F1 plus F2 plus F3, because there is no horizontal force. Next, resultant will be the sum of all forces, since there is only vertical forces. Multiple choice questions. First one, the resultant of two forces P and Q acting along the same straight line but in opposite direction. When forces acting at P and Q are acting in the same straight line, it is acting the collinear forces, but acting along the straight line, but it is in opposite direction, P and Q. P is in this direction, that PQ is in this direction. Then the resultant of the force will be P minus Q. Let's see the answer. Options: P plus Q, P minus Q, P by Q, and Q by P. Answer is P minus Q. Yeah. Next, if the resultant of number of force acting on a body is 0, yes, all the sum of all horizontal force and vertical force, if it is a 0, number of force acting is 0, then the body will not be in equilibrium. This is false. The resultant force, all the forces sigma H equals to 0, sigma V equals to 0, or sigma M is equal to 0. If all the forces are acting will be equal to 0, then only the body is said to be equilibrium. Okay, number of force acting on the body is 0, the body will be not be in equilibrium. No, it will be in equilibrium, because all the forces will be acting at the point will be 0. Options: true or false? It's false. Next question. Is the turning effect produced by the force on the body on which it acts is the turning effect is produced by both produced by a force. A force, they have given A force here, it means a single force. If it was a two forces, then it is called as couple. Now here it's moment. The algebraic sum of their moments about any point is equal to moment of their resultant force about same point. In algebraic sum of the moments, then sigma m will be equal to any point is equal to the moment of the resultant force, that is m the moment resultant force, moment of the resultant force about the same point. Yeah, this is true, but option is law of transfer. Yeah, this is not a law of transfer of the force. Same unit principle, no. Varignon's theorem. Yeah, it's a law of moment. Law of moment is also called as Varignon's theorem. That's the answer. Yes, it's a Varignon's theorem. Next question. Find resultant force in this figure. This is a this is also a coplanar concurrent force. It can be called as coplanar concurrent force. Let's find out first sigma h. What is sigma h? Sigma h here 120 Newton, which is positive, plus 120 minus 55 which is in negative direction because it is in left side direction. Then it will be equals to 65 Newton. 65 Newton. In case of sigma V, sigma V is equal to 70 kilonewton is in downward direction. 70 kilonewton. Sorry, 70 Newton. 70 Newton. This is minus like downward direction, and plus 70 Newton. Both deduct each other. This will be equals to 0 Newton. To find the resultant, we have a formula R equals to square root of sigma h square plus sigma v square. Sigma h square is equal to 65 square plus 0 square square root. The square root of 65 will be equals to 65 only. Resultant force is 65 Newton. Let's see the answer. 65 Newton, 100 Newton, 70 Newton, 120 Newton. Yeah, 65 Newton is the A. Let's see. Yeah, 65 Newton. Next question. If H is 7 Newton and V is 24 Newton, H is 7 Newton, horizontal component is 7 Newton, vertical component is 2 Newton, or it can be called a summation of such into H is 2 7 Newton, or summation of V is 24 Newton. The resultant force will be okay. H, we know H and V. What is the formula of resultant? Resultant is equal to square root of sigma H square plus sigma V square. Here sigma H we know 7 Newton, 7 square plus 24 square. We need a calculator here. It is better when we have a when you are in the video session of SOM, the strength of material course, we have to have a calculator so that to cross verify and get the answer by calculating it in the calculator. Now the answer will be square root of 625 equals to 25. The answer is 25 Newton is there. 25, yeah, it is the correct answer. 25 Newton. Next question. If H is equal to 7 and V is equal to 24 Newton, its direction from north. Very important. Again, to find the direction, the formula is tan theta. Tan theta, we have come across this in the slide. Tan theta equals to sigma V divided by sigma H, which can also called as V divided by H. Okay, theta direction equals to tan inverse of v divided by h. Here tan inverse 24 divided by 7, 24 divided by 7, which will be equals to 73 degree, which will be equals to 73 degree 40 minutes cycle. Theta, as I said, is direction with respect to north we have to find. Then both are here. In which quadrant does it lie? 7 Newton and 24 Newton, which is both positive. Sigma h is positive, sigma b is h and v are positive. In the first quadrant, it will lie in first quadrant. First resultant will be in first quadrant. Then the direction of the resultant will be with respect to x in this touch, 73 degree 40 minutes. But in this case, they are asked the direction from north. We have to deduct north. This is north and this is east. 73 degree 40 minutes. It should be from here. Then 73 degree 40 minutes is the answer. Theta will be equals to 70. Theta will be equals to 73 degree 40 minutes. This is with respect to x, but we need theta with respect to y. When it is 90 minus 73 degree 40 minutes. Theta x is 73 degree 40 minutes. Now with theta y, which is 90 minus theta x, that is 90 minus 73 degree 40 minutes. It will be around 16 degree 20 minutes. Theta y with respect to north is 16 degree 20 minutes. Let's see the answer. 100 degree no, 70 degree no, 70 degree. This is with respect to this can be with respect to the horizontal axis, but they have asked with respect to north direction. 16 degree, yeah, we have got the answer. 16 degree 20 minutes. 16 degree is the right answer. 16 degree is the right answer. These are all. 16 degree is the right answer. That's the answer. Yeah, it's right. 16 degree is the right answer. The next question. No. End of the session. Thank you one and all. I like to acknowledge our team who have, put much effort in bringing this session, a successful session, video session. Thank you one and all. Once again, thank you one and all.